Welcome to the lecture videos on Chapter 34 on electromagnetic waves. This chapter has two main things that we're going to talk about. And one is related to the other one, and it helps you lead to it, but they're sort of separate in their conceptual way you want to think about them. The first one is going to really talk about something called Maxwell's equations, which are the rules that govern both electric and magnetic fields. Um, in principle, from them, you'll be able to find the electric and magnetic fields in any situation. So, like the overall governing rules about how electric and magnetic fields work. And part of what we're going to have to do is have some revision to some earlier rules from magnetism. And we're going to talk somewhat about how to think about these rules. The main point I want to get is not that we're actually going to use them directly to compute anything, which is how most people, usually students, think about equations as just a tool to compute thing. But we're going to really just focus on what is the conceptual meaning of them to get a sense of just like how electric and magnetic fields work. And I think I'll talk a little bit about the relationship between electric and magnetic fields into a combined idea of electromagnetism. Once we have that, we'll find that these rules imply that you should be able to make something called electromagnetic waves. We'll talk about the different property of those waves, like how much energy they carry, how much momentum they carry, which can be also thought of as the intensity of the wave and the pressure applied by the wave. Um, and then we'll go over different types of these radiation that are fundamentally different from each other, but were discovered independently at different times and named differently, and behave differently from each other, but in a smooth transition. So it's just kind of like discovering the trunk of an elephant first and the feet of the elephant and so forth, and it's all part of one object, but a trunk is not terribly like the tail, for example, of an elephant. So that's what we're going to talk about. The part that will most apply for like solving problems will be out of the electromagnetic waves things, because you could make some relatively straightforward predictions about like how bright these waves will be, and how to figure out from a description of electric and magnetic fields how bright something is, and some other properties like that too. The first part with Maxwell's equations, mostly again just a conceptual understanding of these rather than using these quantitatively to solve for something.